Hello students, welcome to another session. So far we have discussed basics of computer generations, characteristics, limitations in the earlier session. Now continue with the another session, and as we see the title of the course is programming in C. We have to know what the basics of a program is. Knowing basics of the program, we have to understand what a program consists of. In a program, there are a set of instructions. Those instructions are framed in a step-by-step way. These step-by-step arrangements will help you, or like you are guiding a person to an address, you will give the directions. Like you go straight, you may reach a junction. In the junction, take the left side. After reaching certain distance, you will find a right direction. In you proceed in that right direction, you will find the address as a fourth house. Like these step-by-step instructions, we will also be writing these instructions in a certain manner. Such instructions are called algorithm. You can see the definition here. In computer science, an algorithm is a step-by-step procedure for calculations. Algorithms are used for calculation, data processing, and automated reasoning. In the characteristics of computer, we have seen the programs. An algorithm is an effective method expressed as a list of instructions for calculating a function. A function can be the calculation, data processing, and reasoning. Starting from an initial state and an initial input, the instructions describe a computation that when executed, proceeds through a finite number, means it is a limited number of well-defined successive states, eventually producing output and terminating at a final ending state. So here it is describing that a limited number of steps, directional, whether it is calculation, data processing, or any reasoning. These finite steps will decide the output. An input will be decided in the output, and it will be terminating the instructions at the end of. So this is an algorithm or definition of an algorithm. So next we will see the characteristics of algorithms. While designing an algorithm as a solution to the given problem, as I said, list of instructions to the problem is solved, whether it is a calculation, either a data processing, or a reasoning. We must take care of the following 5 important characteristics of an algorithm. So here we are discussing about 5 important characteristics of algorithm. So the first one is fitness. An algorithm must terminate after a finite number, means a limited number of steps. And further, each step must be executable in finite amount of time. Means if there is an instruction, the instruction must be processed in some time. Overall, we have to calculate the time. The algorithm must be executed in a finite time and in finite number of steps. Like it has to have any like 4 steps, 5 steps, 250 steps, or this. It should have a finite number. It should be clearly defined. In order to establish a sequence of steps as an algorithm, it should be established that it terminates on all allowed inputs. Like whenever you input something, like enter a number or enter a 2-digit number, when you input something, that has to be executed smoothly. that instruction should be completed without any error, without any delay. So that is finiteness. Finiteness means very clear, very limited, very perfect. Okay. So next one is definiteness. There is no ambiguity. I said very clear. Each step of an algorithm must be precisely defined. Precisely means clearly. Simple means the instruction should be not like a story. You should tell like a just an instruction. The action to be carried out must be rigorously and unambiguously, means undoubtedly specified for each case. Means each step should be simple and clear. There should be no doubt. There is no further thought. When you are in a junction, you should know which direction you should go. There is no further thought that this direction or this direction or that direction or not. You should have a clear and simple instruction. When you reach a junction, you should take right. After taking right, further steps. After that, you reach the fourth house. That is very clear and simple instruction should be given. Okay, like in a simple algorithm, like a simple multiplication, enter a two-digit number or enter a numeric value, means you are just clearly defining that the value should be numeric. There is no other way. Okay, so next, first one is finiteness, second one is definiteness. Next, inputs and outputs of definiteness. In an algorithm has 0 or more, but only finite number of inputs. It can be there is no input or some inputs, but it should be finite. Means it should be having a defined number of just inputs. Like either it is one input or two inputs. Output. An algorithm has one or more outputs. The requirement of at least one output is obviously essential, because or otherwise we cannot know the answer solution provided by the algorithm. Anything as said, if there is zero instruction, the output can also be a zero one. If there is a finite instruction, the output is also a finite instruction. When you give a multiplication, the output is a result of a number. Right? Very clear. The output has a specific relation to the inputs, right? And even the input and the output should be related. When you are giving some numbers to do a multiplication, the output should be a number which is a multiple of those two numbers. The relation is defined by the algorithm, like each step-by-step process. The number should be multiplied by the other number to have the result. The instruction should be very finite, very defined, and inputs and outputs should be very clear. And there should be any relation between the input and output, either it is zero or a finite number. And next characteristic of algorithm is effectiveness. An algorithm should be effective. This means that each of the operation to be performed in an algorithm must be sufficiently basic that it can, in principle, be done exactly in a finite length of time by person using pencil or paper. It may be noted that finiteness condition is a special case of effectiveness. If a sequence of steps is not finite, then it is not be effective also. Means, as said, you should give some simple instructions. You should be giving some simple instructions to carry out in a specific time, in specific number of steps. Once you follow these steps in a principal way, in a sufficient, in a basic way, in a very limited time, it is like a person doing the job, a manual job, how fluent and clear, the system also should have that fluency, finiteness, and effectiveness. Here, the example is given as a person using a pencil and paper to do a calculation. How you instruct him to do that calculation? It is the same way that the computer is also be instructed in such a simple manner, finite manner, definite manner, the relationship between the input and output, and it should be effective. And these are the 5 characteristics of an algorithm. Okay, so next one is define flowchart and explain different symbols used in flowchart. A flowchart is a type of diagram that represents an algorithm or process. As said, algorithm is a step-by-step instruction. It can be theoretical based, word based, but however, in a flowchart, there will be symbols like terminal button, start button, terminal button, processing button, this rectangle based one. There are different types of diamond symbol. These type of symbols are used to understand, to give a different image to the instruction. It is like a diagrammatic representation of the algorithm, showing the steps as boxes of various kinds and their order by connecting them with arrows. Arrows means directions, and again it is direction. This diagrammatic representation illustrates a solution to a given problem. You started from here, and in the next further direction, you will reach the solution. In the same way as algorithm has a step-by-step instruction, you will be representing each step in few boxes. Process operations are represented in these boxes, and arrows rather they are implied by a sequencing of operations. Flowcharts are used in analyzing, designing, documenting, managing a process, or programming various fields. It is like they are used in analyzing, analyzing a problem or a situation, designing a solution, documenting, like you have a series of instructions to carry out a task. In that task, you have to document them. And managing a process, in analyzing or managing a process, or in directing a someone, a procedure, or a program in various fields. The flowchart is used in different fields to make the persons understand. So next one is flowchart symbol list. So what are the symbols that are used in flowchart? A typical flowchart from older basic computer science textbooks may have the following kinds of symbols. Means in olden days, in the earlier stage, like 80s, 90s, or 70s of 20th century, there the start and the end symbol, like I said, the start and end symbol will be in this way. Start button and terminal button, represented as circles, ovals, or rounded fillet triangles. Rounded fillet triangles, usually containing the word start or end. Both the program will, the flowchart will be starting with these one. This this symbol. Another phrase signaling that start or end process, such as submit inquiry or receive product. It is also instructing the person that it is the start or end of the process, such as submit inquiry. You have to submit inquiry and receive product. It is an example. So next one is arrows. Arrows are the directions, like how the process flow is directing. Showing flow of control, arrow coming from one symbol and ending at another symbol represents that control passes to the symbol the arrow points to. Means what it is directing to. That's the next step. What the next step is. What is the result of the previous condition. The line for the arrow can be solid and or dashed. The meaning of the arrow with the dashed line may differ from one flowchart to another and can be defined in the legend. The line from the arrow should be solid or dashed like this way, or this in this way, represented in this way. The meaning of the arrow with the dashed line may differ from one flowchart to another. That has the means you will be defining the line. What is the meaning of the line? Okay. Generic processing steps. Next one is generic, represented as rectangles. Like this one. This is processing. The instructions given in this one process. Example: add 1 to x. Like you took the number x. Now in the instruction, in the processing box, the processing, you will be adding like add 1 to x means it will add x plus 1. We add in the box, add 1 to x means the next step will be x plus 1. Replace identified part, save changes or similar. So once this instruction is completed, the other executable instruction will be proceeded. So next one is subroutines. Represented as rectangles with double struck vertical edges. Double struck vertical edges. These are used to show complex processing steps which may be detailed in a separate flowchart. Example: process files. Like when you represent them in these subroutines, these means these flowcharts, the process in this subroutines has to be detailed in a separate chart process. Like there is a program, but several sub programs are there in that sub instructions. Various sub instructions, sub files has been processed. In that, you will be having the subroutines. One subroutine may have multiple distinct entry points or exit flows. See coroutine. So if so, these are shown as labeled wells in the rectangle, and control arrows connect to these wells. Okay, so each instruction can be, it has a different direction. One is flowing in a different direction, like 3 subcategories. In that way, you will have all these programs, but everything has its own result, or they will meet at a juncture and be processed. Like you have an instruction like yes or no. By yes, you will proceed to the end step. By no, you will have another process. Okay, true or false. These are kind of, you will have some multiple choice for problem statements. In that way, these subroutines will have their importance and their flow. Next one is input or output, represented as a parallelogram. Examples: get x from the user, display x, like this way. So next one is finite input and output. Next, prepare conditional, and represented as a hexagon. Hexagon will have 6 hexagon, show operations which have no effect other than preparing a value for a subsequent condition or a decision step. Okay, so the particular preparing conditional will have no such things. It is like a junction. It will direct you to the next step. Conditional or decision, represent as a diamond or rhombus. As said, the diamond symbol, like this one. From this, either yes, you will proceed to this direction. If this direction, and we have next step. True or false, yes or no. These are the conditions as said in the input or output, as discussed in the earlier minutes. We have these conditions. The arrow should be labeled. More than 2 arrows can be used, but this is normally a clear indicator that a complex decision being taken, in which case it may be need to be broken down further or replaced with predefined processor symbol. Okay. Next one is junction symbol, generally represented with a black blob, showing whether multiple control flows converge in a single exit flow. A junction symbol will have more than one arrow coming into it, but only one going out. Like you may have multiple instructions coming to the one direction, and you will have one output. In simple cases, one may simply have an arrow point to another arrow. Instead, they are useful to represent an iterative process. What in computer science is called a loop. A loop may, for example, consist of a connector where control first enters processing steps, a conditional with one arrow exiting the loop and one going back to the connector. Means in a loop, you have one instruction and it will be executed. But however, in this loop, the loop has to go back to the instruction. As said, add 1 to the x. 1 plus x means once this instruction is executed, if this is a loop, again the another number should be added so that the result can be 1, 2, 3, 4 and so on. Once the result is done, it has to be go back to again. Okay, so this is all. For additional clarity, wherever two lines accidentally cross in the drawing, one of them may be drawn with a small semicircle over the other, showing no junction is intended. Labeled connectors, represented by an identifying label inside a circle. Labeled connectors are used in complex or multiple sheet diagrams to substitute for arrows. For each symbol, the outflow connector must always be unique, but there may be any number of inflow connectors. In this case, a junction in control flow is implied, represented by an identifying label inside a circle. Labeled connectors are used in complex or multi-sheet diagrams. Substitute for arrows. Like these labeled connectors will have circles. In a circle, you have labeled connectors. These have, they will be unique, but there may be a number of inflow connectors. Next one is concurrence symbols, represented by a double transverse line with any number of entry or exit arrows. These symbols are used whenever two or more control flows must operate simultaneously. These exit flows are activated concurrently when all the entry flows have reached the concurrency symbol. A concurrency symbol with a single entry flows is a fork. One with single exit flow is a join. All process should flow from top to bottom and left to right. So here as a label flowchart, we have circular symbols. In the concurrency symbols, like we have certain rectangle certain operations which are carried out simultaneously. So here we have certain symbols. This is a process symbol, rectangle, terminator as said, start, decision, predefined process as said. Here we discussed like parallel, rectangle and straight lines. Alternative process we have it is having some curved rectangular curves. Like data input and output, we have parallelogram, and then document, multiple, we have preparation, we have display, punch tape, transfer, logical instruction, summing instruction, collate, sorting, merge, extract, magnetic disk or database, initial flow line, as said here. So these are the symbols which are used. However, very important symbols are these: terminal button, start and stop, processing, decision making, data input output. These are the very important symbols in a flowchart. Flowchart is a diagrammatic representation of the instructions. We will see further questions in the next session. We have understand the basics of an algorithm and a flow. We'll continue the chapter in the next session. Thank you.